about derivatives then, and we're going to use the limits that we just got off of in Chapter 1. So using the limiting process to find derivatives. Basic concepts are these. If you pick a value, an x value, and you pick one that's kind of close to it, let's call it x plus some constant h. This could be 2, this could be 3. In this case, h would be 1. This could be 2, this could be 2.5. In this case, h would be half. Obviously, it could be 2 and 2.1, and h would be 0.1 or a tenth in that particular case. So what we find out is if we let h approach 0, then basic concept is we are now not talking about a secant slope anymore. We're talking about a tangent slope. So we use the limiting process to turn a secant slope into a tangent slope. So we're going to start off by letting you know that a simple function such as a linear function, f of x is equal to 2x plus 1, which is the same thing as saying y equals 2x plus 1, we know the slope of this line. This line is in the form of y equals mx plus b. Therefore, the value m here, the coefficient of x, which is 2, or 2 over 1 stated as a fraction, it's slope 2 for all x values. We know that's the case. So let's see if using the limited process we get the exact same thing. Okay, so f of x is equal to 2x plus 1. So now, how do you denote a derivative? We use this notation, f prime of x, or sometimes they use the notation a derivative with respect to x. This is what the d dx means, derivative with respect to x of the function f of x. Both of these mean derivatives, they both stand for rate of change. They both are going to give us a slope, a tangent slope. So again, like we talked about before, we're going to take the limit of h approaches 0 of the differences in the y's over the differences in the x's, and that comes off this picture up here. We got the y values of f of x plus h and f of x, and the x values of x plus h and x. So we're going to subtract those two things, and we're going to let h approach 0. So if using the composite things that we just talked about last video, we plug these things in, what happens? 2 times the quantity x plus h plus 1 comes in the first part. This is f of x plus h minus f of x. The 2x plus 1 is simply the function f of x, all over h, because the two x's cancel out here. And this is still the limit as h approaches 0. So let's see where we go from there. We distribute the 2, so 2x plus 2h plus 1. And we've got to remember to distribute this negative here. This becomes negative 2x and becomes minus 1. Okay? Any negative in front of a parentheses needs distributed. So the 2x and the 2x cancel, the 2h stays, and the 1 and the negative 1 cancel. So we're left with 2h over h, which as we cancel out the h's as h approaches 0, we don't even have anywhere to put it in. We've just got 2 over the 1, which is the slope of f of x, or we could call this, we have just found f prime of x, or for that matter, the derivative with respect to x of f of x. What's the derivative? 2 over 1. Were we expecting the slope of that line to be 2? Yes, we were, because the thing is linear. Good enough.